Hi, Maya. What kind of cookies are you making? All right, so this is Unit 8, Lesson 1, Square Root Functions. Your homework tonight, I was going to make it in Khan Academy, but I just wasn't a fan of how the questions were worded based on our notes. So your homework for tonight is going to be numbers 1 through 6 on the Unit 8 Homework 1 worksheet. It's in the Unit 8 folder, ooh, chocolate chip, in the Files tab of Teams. So obviously I don't expect you to have to print it out. Like, I don't even own a printer. So if you want to just do your work on a separate sheet of paper, make sure it's numbered and organized for me, you can just email me a picture of it and then I will look at it that way. So let us begin. So consider the function f of x equals radical x and graph it on the grid provided. Determine an equation. Okay, so what you have to do is, if you're following along with your calculator, you're going to go to y equals, you're going to go to second squared x, and then we'll do second graph to get our table right away. We're only going to graph the pretty points. So we'll notice that the first pretty point we get is 0, 0. And then the next one is 1, 1. And then we have 4, 2, 1, oops. 1, 2, 3, 4, 1, 2. Let's get another pretty point. 9, 3. 4, 5, 6, 7, 8. Oh, okay, computer, let's just scroll everywhere on me. 9, 3. Okay. So it's going to look like that. So y equals radical x. Obviously, if you don't have graph paper, that's fine. You can just sketch this down. So that's our original function. And if you look at the table, you'll notice anything before 0, you get an error, which makes sense because if you're going to plug in -1 under that radical, as we learned last time, we're going to get an imaginary number. So that's not going to work out. So next is determine the equation for the function. Oh, I should have named that as f of x. My bad. I'm going to fix that first. There we go. F of x. Much better. All right. So determine the equation for g of x if the original function is shifted left 3 and down 2. So this is like what we were doing last unit. So for g of x, if I'm going to shift it left 3, that's going to be under the radical. So I'm going to do x plus 3, because remember it's going opposite of what you would think. And then down 2 is on the outside, and it's -2. So very similar to what we were doing in Unit 7. And then we can graph this. So what I'm just going to do is you can go into your calculator and type this in, or you can just physically move the points how they're describing them. So left 3 and down 2. Left 3 and down 2. Left 3 and down 2. Left 1, 2, 3 and down 2. And if you look in your table, you'll notice that anything before or to the left or low of that first point, it's at -3, -2, is going to also give you an error message. So, and this is g of x equals radical x plus 3 minus 2. All right, so we see it's lower and down, just shifted. Okay, so using this information, determine the domain and range for both functions. Remember, we don't want a negative under the radical. Oh, excuse me. So let's do f of x first. So the original one that we graphed. So remember, domain is like your x, range is like your y. So if we're talking about domain, let's see. It looks like we start at 0 and we go off into infinity. Just keeps going and going and going. For range, we're looking low to high. So again, we're at 0. And then we go off into infinity as well. It's a really bad infinity symbol. There we go. A little better. All right. So g of x, a little different. For our domain, looks like the most left we're going is -3. And we're still going off into infinity. And then the range, the lowest we go is -2. And we're still going off into infinity. Okay. Next, still connecting to what we did last unit, state the transformation that has occurred to the function below. So radical x is the parent function for square root functions. So what we can see is it looks like this has been reflected and shifted. So let's do the shifted first. So normally we would have started at the origin, but now we're hopping over 1, 2, 3, 4. So we shifted left 4. And we also reflected over the x axis. But it looks like our width, like it didn't get skinnier, fatter, or anything like that. Cool, cool, cool. All right. Next, which of the following values of x does not lie in the domain of radical x minus 5? Explain why. So what we're going to do is we just plug them in, see if we get something true. So let's say we start with a. So we have radical x minus 5. So if x is 6, we get 6 minus 5. So y equals radical 1, which we can simplify. Radical 1 is legit, right? So that one works out. It is in the domain. Let's try like 2. So we get y equals 2 minus 5. And we get the square root of negative 3, which is not allowed. That's going to give you an imaginary number. Imaginary. So that one can't possibly lie. Let's see if there's any others. Let's try, oh, that was B. This is C. Let's try y equals radical 5 minus 5. We get square root of 0, which is allowed. So that one works out. And let's try radical 7 minus 5. We get not D, silly me. We get radical 2, which is allowed. It's just not rational, but it is legal. So it's just 2 because we get that negative under there, that imaginary number. So if we want to find the domains, which is what a lot of your homework is going to be on, we're going to practice that in these next 4. So these next 4 are super duper important. Make sure you take good notes on them. Determine the domain. So that would be the value under the radical must be greater than or equal to 0. We're allowed to be equal to 0, but we don't want to go smaller than that. So all we're going to do is we're going to take whatever is under the radical and set it greater than or equal to 0. And then we solve for x. So here, the x's have to be greater than or equal to negative 2. You can have negative 2, you can have negative 1, you can have 0, you can have 11, but you can't have like negative 3. Not allowed. So let's try the next one. 3x minus 2 is greater than or equal to 0. So we're just going to solve for x. We get 3x is greater than or equal to 2. And then x is greater than or equal to, to 2/3. So a fraction, but nonetheless valid. That was a little messy. All right, next we have 8 minus 2x has to be greater than or equal to 0. So let's subtract over 8. And then I'm going to divide by negative 2. But recall, when you divide by a negative, your inequality is going to flip. So here, any x that is smaller than or equal to 4 is allowed. So that one's kind of a unique one. Let's do one more. I'll zoom in. Get negative 4x minus 7 greater than or equal to 0. We add 7. We divide by negative 4. So remember, dividing by a negative, your inequality is going to flip. So we get negative 7/4. So that is your restriction. Okay, do a couple more examples, and then we'll call it a day. I'm going to skip that one because I don't really care about graphing. So let's do one where it's a little bit more exciting, where we have like a quadratic involved. So we're still going to do the same process. where we have to be greater than or equal to 0. So this is difference of two perfect squares. Dots. X plus 2. Oh, x plus 2. My goodness. X plus 11. And x minus 11 is greater than or equal to 0. We'll drop down our t-chart. So x plus 11 can be greater than or equal to 0. X minus 11 is greater than or equal to 0. So x can be greater than or equal to negative 11, or x can be greater than or equal to positive 11. So it's one of those. One of those. Okay. Let's do one more. So this one's just going to be a normal quadratic. So that's going to factor into x and x. We are multiplying to get a negative, which means my signs are going to be different. And let's see, I got to combine to get 17. So let's do positive 20 and minus 3. Drop down our table. So x plus 20 is greater than or equal to 0. X minus 3 is greater than or equal to 0. So x is going to be greater than or equal to negative 20. Or x is going to be greater than or equal to 3. Cool. Actually, we'll do the next one because that one factors a little fun too. So that was a regular one. This is one where your a value is not equal to 1. So the only way to break that up is going to be 7x and x. So it's nice when it's prime at least. So this is one where you have to do a little guess and check. So it might take you a couple times to factor it, but that's okay. No big deal. We're multiplying to get a negative and, multiplying to get a positive and combining to get a positive. So both of these are going to be pluses. Then I got to think of my factor pairs for 36. Let's see. Well, we obviously have 36 and 1. We have 4 and 9, 6 and 6. And we got to remember, whatever is going to be in this spot over here is going to multiply by the 7. So let's try 4 and 9. So let's do plus 4, plus 9. 7 times 9, 63. Plus 4 is 67. So that one does work. Whee! So we get 7x plus 4 is greater than or equal to 0. X plus 9 is greater than or equal to 0. 7x is going to be greater than or equal to negative 4. And then we got to divide by 7. So it's a fraction, but that's okay. Or we get x is greater than or equal to negative 9. So, oh, it's up there. So that is your notes for today. Again, your homework is in the Files tab. Let me know if you need help locating it. You should be able to locate it if you've been looking at the homework I've been posting, because you just got to click into class materials and you'll see the Unit 8. So, have a fabulous day. That homework is due on Friday. Just email it to me again, a picture of it, or if you want to join me on my Zoom office hours, that's fine too. Tomorrow is from 10 to 11 and 1 to 2. So hop on if you'd like. We can even work on some of it together. No big deal. And I will be back live on Monday. So, have a fabulous day.